Hello, and welcome to another Algebra 2 lesson. This is lesson 9.3. Our objective, find trigonometric functions of any angle. Any angle. Means it can be more than 180, it can be more than 360, it can be negative, positive, it can be in radians or degrees. Angles in standard position. Angles in standard position start at the positive x-axis, and positive angles go counterclockwise. So for this first blue angle, its starting spot would be the positive x-axis, and it goes to here in a counterclockwise direction. Now, that's standard position. To find the trigonometry ratios of any angle, we're going to draw our angle in standard position, but then draw a reference triangle which must go to the x-axis. We will then label a theta prime for the reference angle at the origin. So the reference angle, a reference triangle, and a reference angle will always go to the x-axis. So this blue one, we would make a right triangle here, and our theta would be here. For the red one, we're still going to go to the x-axis, but because this is actually representing an angle here would be the theta, this angle at the origin would be our theta prime. Theta prime is our reference angle. It's always an angle that uses the origin, and it is always less than 90 degrees. This green one, would go to the x-axis as well, so that the right angle is here, its reference angle is here, and this purple one would also go to the x-axis with the right angle here, reference angle at the origin, theta prime. So a reference angle is always at the origin, and it's always less than 90 degrees. General definitions of trigonometric functions. Let theta be an angle in standard position. Let xy be the point where the terminal side of theta intersects the circle. X squared plus y squared equals r squared. The 6 trigonometric functions of theta are defined as follows. So if they give us a point that will help us, the x will be how long is this, and x in this direction would be a negative x, and how far is this to get to that point, that would be your y, and whatever that x value is, x value would give you the cosine x over r because that's adjacent over hypotenuse. Sine is opposite over hypotenuse, so that would be y over r. And tangent is opposite over adjacent. So we are using the theta prime, the reference angle, and this reference triangle to get these trig ratios. These functions are sometimes called circular functions. Let negative 4, 3 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions. So we have this triangle. Has the right angle here, and this is our theta prime, our reference angle. If this point is negative 4, 3, then this distance here is the x value, that's negative 4. And how far up did we go? 3. So notice we're going to use some negative numbers. Now, we need to find this hypotenuse. If it was a unit circle, the radius is 1, but this is not a unit circle or a circle with radius 1. So we have to find that radius. Here's some common Pythagorean triples. We could do 3 squared plus 4 squared equals r squared and solve it, but 3, 4, 5 comes up a lot. If you have 3 side lengths of a triangle that are 3, 4, 5, it's always a right triangle, and multiples of that, 6, 8, 10, or if we did times 3, we would get 9, 12, 15. If we did 3, 4, 5 times 4, we would get 12, 16, and 20, and so on. Some other common Pythagorean triples are 5, 12, 13, and multiples of those. All right, so this radius is 5. We can now find our 6 trig functions. So you can tell Oscar had a heap of apples. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent, make sure you use the negative. And then tangent. Tangent is opposite over adjacent. Opposite over adjacent. And then do the 3 reciprocal functions. Cosecant, the one with the s in the middle, is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is a reciprocal of tangent. So write those out. So flip it over. These are reciprocal functions, reciprocals of the others. You can put the negative with the 5, with the 4, or out front as long as there's just one negative. Again, you can put the negative out front with the numerator or the denominator, and it is still a negative answer. Evaluate the 6 trig functions for theta. All right, that's what we did, all 6 of them. So label your triangle. Label where the x goes and where the y goes. Remember, x is sideways and the y value is up and down. Find your radius for your hypotenuse, and then do your trig ratios. And that's example 1. The unit circle. If we make the radius be 1, we call this the unit circle. It's 1 unit, so r equals 1. The circle x squared plus y squared equals 1, which has center 0, 0, and radius 1, it is called the unit circle. The values of sine theta and cosine theta are simply the y-coordinate and the x-coordinate, respectively, of the point where the terminal side of theta intersects the unit circle. So if we have some point xy, we could create that triangle. This would be your x, this would be your y, and r is 1. So y over r is y over 1, or just y. Cosine is x divided by r. That's your adjacent over your hypotenuse. Looking at this angle, the reference angle, adjacent over hypotenuse would be x over r, or x over 1, which equals just x. So the x and y coordinates, when we're on the unit circle, circle with radius 1, is cosine of theta and the sine of theta. Then to find tangent, tangent is opposite over adjacent. Opposite over adjacent. So that would be y over x. Funny thing is, y is sine theta, x is cosine theta, so tangent is also equal to sine of theta divided by cosine theta. Or as we more commonly say, sine over cosine. Tangent is sine over cosine, or y over x on a unit circle. All right, which angles can we not draw a reference triangle for? I drew a triangle here so we could kind of see the opposite, adjacent, and hypotenuse. But what if it were here? We're supposed to draw it always to the x-axis. That doesn't give us a triangle. So those angles on the axes, when that point is on an x or y axis, can't draw the reference triangle. And those are called quadrantal angles, because their terminal side is at the border of some of the quadrants. Quadrantal angles. So if we're ever here, 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 and here, one of those 4 points, those are quadrantal angles. But we can still use the x and y. For this point, that is the point 1, 0. And the cosine will be 1, and the sine will be 0. For this point, remember the circle radius is 1. That's 1, 0. This point over here, we went backwards 1, so that's negative 1, 0. And here we went down 1, so we went 0 sideways and 1 down, so that's 0, negative 1. All right, unit circles, very, very important. You're going to hear about the unit circle and use the unit circle every day for probably the next 2 weeks, maybe longer. Use the unit circle to evaluate the 6 trigonometric functions of theta equals 270. They gave you the coordinates of the point. I like to write out cosine sine for my x and y. And I typically will write it without the theta, because when you do that, the s's are in the middle. It just helps me remember whether it's cosine sine or sine cosine. Because when we do our soup can't tell, Oscar had a heap of apples, or SOHCAHTOA, we always do sine first. So you need to make sure when you're doing the x and the y that it's cosine theta, then sine theta. S is in the middle. All right. Let's do this. Sine, cosine tangent, sine is the y value, cosine is the x value. Do you remember what tangent is? Tangent is sine divided by cosine. We just found the sine and the cosine, so it's negative 1 over 0. But we can't divide by 0, so that's undefined. Now find your reciprocal functions. What is the reciprocal of sine? Cosecant, the one with the s in the middle. Do the reciprocal. So that would be 1 over negative 1. So that's still negative 1. The reciprocal of cosine. The reciprocal of 0 becomes 1 over 0. Can't have a 0 on the bottom. Division by 0 is undefined, so that's undefined. And the last one, what is the reciprocal function of tangent called? Cotangent. So the reciprocal of undefined actually turns out to be 0. Look at my fraction. If I flip that over, 0 over negative 1, well, that's just 0. And there's our 6 trig functions of 270 degrees. And that's example 2. We use the unit circle to find our values of our trig functions. Ooh, the more we practice, the better we get. Find the sine, cosine, and tangent of the angle theta in standard position whose terminal side intersects the unit circle at the point shown. This is the unit circle. all of these are a unit circle. That means the radius is 1. And because the radius is 1, our x and y is going to be our cosine sine. Remember, s is in the middle. It's cosine theta, sine theta, but I like to see those s's in the middle. So this is your cosine. This is your sine. So sine of theta equals rad 3 over 2. Cosine of theta, negative 1/2. Then tangent, the sine divided by cosine or cosine divided by sine? Which way does it go? Tangent is y divided by x or sine divided by cosine. So sine divided by cosine, we have rad 3 over 2 divided by negative 1/2. Well, if we multiply by 2 over 2, the 2's cancel out. We get rad 3 over negative 1, which is just negative square root of 3. Just ask for sine, cosine, tangent. We're not doing all 6. We're just going to practice the main 3. Sine, cosine, tangent, sine, cosine, tangent. Do it again, do it again, do it again. Here we go. Cosine, sine. Can't leave it 1 over rad 2. We got to simplify it. Multiply by rad 2 over rad 2. Then we get rad 2 over 2. And cosine. Cosine on the unit circle is the x value, so that's negative 1 over rad 2. When you multiply to rationalize the denominator, you will get a negative rad 2 over 2. And tangent. Sine divided by cosine. Hey, these are the same number. Did you notice? But one's positive, one's negative. So rad 2 over 2 divided by negative rad 2 over 2. What's that going to be? That equals negative 1. All right, keep going. You may want to pause and try some on your own and then check your answers with mine. All right, check your answers. How'd you do? Whew. That's finding our trig functions using the unit circle. Let's see what's next. Reference angles. Reference angles are the closest angle to the x-axis. That's our theta prime. I mentioned those earlier on the very first page. But here's how you mathematically find them. When you're in quadrant 2, you're going to do 180 minus the angle. Or if you're doing radians, it would be pi minus the angle. So remember that over here is 180 degrees, which is also equal to pi if we're using radians. If you're in quadrant 3, you're still comparing to 180 or pi, but you're doing the angle minus 180 or the angle minus pi. When you're in the fourth quadrant, you're going to do 360 minus the angle or 2 pi minus the angle, because all the way around is 360 degrees, which is equal to 2 pi. So here's the mathematical way to find your reference angles for any of the quadrants. If it's in quadrant 1, we don't need to find a reference angle because it's already less than 90. Remember, reference angles are always less than 90 degrees or less than pi over 2. They're always acute angles for the theta prime, the reference angle. Reference angles are always less than 90 or pi over 2. How far away are they from 0, 180, or 360? Use the closest one. Okay, so 100. How far away from 180 is that? 80 degrees. 200. Is that closest to 0, 180, or 360? 200 is closest to 180. And how far away from 180 is it? 20. And then what about 300? Which one is it closest to? And then how far away from it is it? 60. Okay, those are some extra examples I threw in. Let's do the official example 3. Find the reference angle, theta prime, for the given angles. 5 pi over 3. How far away from 0, pi over 2, or pi is it? Oh, or 2 pi. Because 5 pi over 3 is actually closest to 2 pi. Remember, this is 1 pi, and all the way around is 2 pi. 5 pi over 3, that's 1 2/3. So it's going to be over here. How many more thirds to get to 2 pi? 2 pi is really 6 pi over 3. Can be written as 6 pi over 3. 5 pi thirds and 6 pi thirds. If we subtract those, smaller one from the bigger one, we will get our reference angle. Pi over 3. All right, how about the next one? Which way do we go for negative angles? Going to go the opposite way. So negative 130. Let's draw a picture. If we start from here, this is 90 degrees, so we need to go another 40. So negative 130 is here. So how far away is that from 180 or from even negative 180? How far apart are those? That gives us our reference angle. 50 degrees. $50 apart. And there's your reference angles. Now, we can use reference angles to find sines, cosines, and tangents. But we can also use coterminal angles. So I actually use coterminal angles more often than I use reference angles. Reference angles are handy when you can draw a triangle. Here's our unit circle with all of the angle measures drawn on here, 30, 45, 60, 90, and then all of the other ones going around in multiples of 30s and then in multiples of 45. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Notice when I count by 30 degrees, when I count by 30s, I'm jumping over the 45, 135, all the ones that end with 5s. Then we can also go around the whole circle counting by 45s. 0, 45, 90, 135, 180, 225, 270, 315, and 360. These are the points, the coordinates of the points on the unit circle. We need to know these for all of the unit circle. I'm going to give you a reference sheet that has all these labeled on there. But when you get to the point to where you can memorize them, it is even faster to get to our answers. Okay, these are symmetrical. So if this is 1/2 rad 3 over 2, then this one that's straight across from it, the x is just in the opposite direction. So that's negative 1/2 rad 3 over 2 because the x went in a negative direction. So that is the coordinates of the point. And we want to label these all the way around. Here we go. This next one is straight across from this one. So the numbers are the same, but the x went in the opposite direction. So that's going to be a negative rad 2 over 2. But the y value is still up. So that's positive rad 2 over 2. And the next spot, 150, is symmetrical with this 30. It's straight across from that. So just the x value is negative. So we have a negative rad 3 over 2, 1/2. And then what's the coordinates of this point? This is 1, 0, so that told us that it is definitely a radius of 1. So if we go the opposite direction, that's negative 1, 0. All right, let's do this quadrant 4 next. Because if we look this way, compare this point to this point, the x's are exactly the same, but the y values are opposites. So now this is rad 3 over 2 with a negative 1/2. And this middle one, the x value or the y value going to be negative? The y value, because we went forward but down. Right, keep going, keep labeling around your circle. That goes with the 315 degrees. Now this next one, that one lines up with this one. So forward 1/2 and down, so negative rad 3 over 2. That's this one right here, the 300 degrees, and then 270. pause your video, label the rest of your dots. So the last quadrant, you could compare it to the one across from it to label all your points. All right, I moved a couple things around. So if you look at this point, this one, these 4 points, notice they're all the same numbers, except for the signs change. They're all 1/2 rad 3 over 2, but here the x value is negative, here x and y are negative, and here just the y value is negative. But those 4 match. Notice if you go here, these are all symmetrical because they all have the same reference angle. This is a 30-degree reference angle. This is a 30-degree reference angle. So is this, and so is this. They all have a reference angle of 30 degrees. Only the signs that change. All right, there's more on the unit circle. Here it is all filled in with for you with the degree measure, the radian measure, and the coordinates x and y. As long as we are on the unit circle with radius 1, then the sine of theta is your y value, cosine of theta is your x value, and tangent is y divided by x. Keep this handy. We'll come back to this page often. All right, example 4. Evaluate tangent of negative 240 and cosecant of 17 pi over 6. They want you to use reference angles. You can use the reference angle and create a reference triangle. So if we have this reference triangle, this reference angle is 60 degrees. This is one. If you think through 30, 60, 90 triangles, 30, 60, 90 triangles are in the proportion x, x rad 3, and 2x, but we know our radius is 1. If our radius is 1, then the short leg is 1/2, and the long leg is rad 3 over 2, or 1/2 times rad 3. We can draw and label this triangle using that information. Tangent is the opposite over adjacent from our triangle, or you could think of it as the y over x. So the coordinates of this point would be the 1/2, negative 1/2, and rad 3 over 2. So when I drew my reference triangle over here, I did not label my negative. My x went in a negative direction. So we need a negative 1/2 there. So our final tangent of 240 degrees, our tangent of negative 240 degrees equals rad 3 over 2 divided by negative 1/2, which equals negative rad 3. Now, that was using the reference angle and drawing a reference triangle. We could have just used the coterminal point on the unit circle. Let's take a look. So 60 degrees away from this x-axis, 60 degrees, that would make us at 120. So here's the coordinates. Negative 1/2 rad 3 over 2. We were doing tangent, so y divided by x. Y divided by x. There it is. So you can skip this stuff if you use your unit circle. All right, part B, cosecant of 17 pi over 6. 17 pi over 6 has a reference angle of pi over 6. Here's what it looks like. Let's take a look at what point that is on our unit circle. Pi over 6 away from that negative x-axis. That would be coterminal with 5 pi over 6. So this is our cosine and our sine. but we need cosecant. Cosecant is the reciprocal of which one? Reciprocal of sine, yes. So cosecant of 17 pi over 6. To do that, we're going to find the sine of 5 pi over 6. What was it? The sine of 5 pi over 6 was 1/2. Right here, cosine sine. Sine is the y. So cosecant of 17 pi over 6 is the reciprocal of that. What's the reciprocal of 1/2? 2. All right, I know this is getting pretty complicated. It's a lot to process, but the more we practice, the better we get. You will have an assignment for 9.3 on big ideas, and you will also have a worksheet that we can do a lot of it together once I give you a paper copy of this beautiful unit circle. So you will be getting a reference sheet with that. But you can also Google it if you don't want to wait for me to give you one, and download a copy of the unit circle. Right, that's all we need to know for Big Ideas Assignment 9.3. There are more examples on the following page. I'm going to end this video here, and I will make a part 2 with the additional examples.